All right, number 5. Number 5 is a question that's about a pendulum. It's written in a very weird way, so I'll let you read it, and then I will go through it. All right, the beginning is just a fancy way of saying that this is a pendulum, like I mentioned. I want to point out a few things. So you can see I drew here, and I'm going to show you with my key pendulum here. So it's oscillating back and forth. What it's saying is the equilibrium position, that's the point that a set of keys like this would hang to naturally. That's the equilibrium position. What we're saying is that we're lifting at a height h above that. So it's some amount like this much higher than it. You can see I drew that here as well. So we're lifting it up just a little bit, and then it undergoes simple harmonic motion. Which of the following methods could a student use to determine the total mechanical energy at position y? So position y is right here, the equilibrium position. Okay. Now what you folks know is that energy is conserved. So for example, here it's going at some initial or some speed. It's actually going to be its largest speed. We know that that's going to be all kinetic energy at that moment. And when it's lifted and pulled up to a height h, we know that it's going to have all gravitational potential energy. So the beautiful thing about that is we could actually calculate it. If we knew mgh, we could calculate the total potential, which would give us the total mechanical energy. Remember, mechanical energy is just Pe plus Ke. Or we could find, if we know the mass, which we do, and we knew the speed as it passed through point y, the equilibrium position, we could find Ke. At that moment, there's no potential energy. It's all kinetic. So we could do it either way. So I want to show you why C and D are definitely the correct answers, and let's talk about why A and B are definitely wrong. So C is just saying use the kinetic energy equation. That'll work. That'll tell you what the total mechanical energy is if you do it at position Y. So that's correct. That makes sense. And then D is just saying, well, use the gravitational potential energy equation. And if you did that, it will have no gravitational potential energy when it passes through the equilibrium position. So D is correct. This one I think is helpful to see. Those are the two correct ones, but it's also helpful to see why A and B are wrong. So this is saying the total mechanical energy E is going to be the difference between the kinetic energy and the gravitational potential energy. If you did that, what you'd end up with is 0. You'd take Ke minus Pe and you'd get 0. The kinetic energy minus the potential energy at point y versus at height h would just be 0. So this would give you E equals 0, and that's nonsense. Same thing here. This says take the potential and minus the kinetic. That's also kind of nonsense. Okay? So these are both wrong. This one, I think, is one where you may be tempted to take a more complicated looking answer because you're in a hurry. This is really just saying you can calculate the kinetic and it will tell you the total mechanical energy at any moment after that. And this is just saying find the total potential energy and it will tell you the total mechanical energy. So I'm hoping that makes sense. This one is perhaps simpler than you think for being a select two answers style question. That's it for number 5.